Now we shall open it. How does it look? Is it readable? Looks like it is.
Yeah, I think maybe a little bit, like zoom in on the whole. Yeah. Maybe even one more.
Okay. So Minnow is this ABCI state machine that I started working on. If you're familiar with Rust, one thing I like to do whenever I open up a Rust code base is I just go straight to the cargo.toml file, and I go under dependencies to see what is this thing importing. So far I've imported a signature library, tower, and a Merkle tree, mono tree, which is a sparse Merkle tree. I've also imported the Celestia types because this specific project is Celestia specific. Minnow in its current form is seeking to implement, well, I mean, it seeks to be a fraud provable state machine. So, and one of the ways that it tries to be fraud provable is it uses its own serialization scheme that I came up with rather than doing protobufs or Borscht or something like that, because the way that Celestia works is it breaks blobs up into shares, and then it has the blob commitment. And in the header to your block of your rollup blockchain, you want to have the commitment to the blob for the block body. And then fraud proofs, you want your fraud proofs to be in the form of like share inclusion proofs. So you want to prove a Merkle path to some share that has fraud in it. And so Minnow includes share aware serialization, which I just kind of rolled it from the ground up to be this very like simple serialization scheme, which I will show you right now. So in the transaction file defines a very simple transaction struct, which has the 32-byte sender pub key, the 32-byte recipient pub key, and then an amount, which is like an amount of coins. I don't have fees in Minnow right now, so at the moment, Minnow does not have any way of collecting fees from users. And then there's the signed transaction struct, which has a signature and then a serialized transaction. So if we go to how the serialization works for a transaction, you'll see that it literally just creates a 72-byte buffer, and then it just copies the 32 bytes from the sender pub key into the buffer, and then it copies the recipient pub key, and then it copies the amount. So this is just the most minimal serialization scheme you could possibly think of. And we're rolling our own share-aware serialization. A share is 512 bytes. So this is just 72 bytes for one transaction. So we know that at least like several of these could fit into one share.
What does share aware mean?
What
does that mean?
So basically, we just have to think about all the data structures. Because we want this to be fraud provable, we want like one share. We don't ever want like a transaction to span across multiple shares of the blob, because we want like a single share proof to be usable as a fraud proof.
Got it.
So we don't want to use protobuf because protobuf is not share aware. Protobuf is this general purpose thing. Yeah, so I have tests somewhere. Oh yeah, yeah. So anyway, that's transaction. The sign transaction, like you can call the sign method on a TX to sign it. It also just serializes it for you. in the block abstraction, we have incoming blocks. And then we have the notion of transaction ISR pairs because this is fraud provable. It gives you the state root after the result of executing each transaction. There is code for ABCI somewhere. I guess I can, oh yeah, so here's the ABCI stuff. We import the Tendermint crate, and the Tendermint crate has the ABCI module. And you can think of your app chain state machine as like a server that takes ABCI requests and it returns ABCI responses. So we have the init chain requests, the prepare proposal, process proposal, and finalize block. So Rollkit gives us a request to initialize a new chain. For each block, it requests like transactions to go into the block. And for process proposal, it validates a block that it received. And then finalize block is where it actually like executes the block and writes to the state machine's state store. So we have in the state, we have these account balance pairs where it just maps a pub key to the pub key's balance. Yep. We have serialization code for these. The state of the minnow state machine, it keeps track of, the chain ID. It has the Merkle tree, the state root, which is just a hash, the current block height. And this is the stuff that I haven't worked on in a while, and I need to blow the dust off of it. It keeps track of state diffs. It keeps track of the non-committed state root and like the current pending block. All right, so then there's this call function, state.call. And here is where we have all the different ABCI methods. And then like when it receives an ABCI request from Rollkit, it will call some function in minnow. So like here's what we can go look at what the init chain. So we can look at this type. I think that might be good to look at. Uh-oh. No definition found. Rust analyzer. Oh, maybe because my tree does not exist. My tree does exist. But that path is probably wrong. Oh, maybe my Poseidon hash does not exist.
What's the TLDR on the Poseidon hash?
Oh yeah, this code base is a little bit of a mess because at one point I thought I was gonna pivot it into being a ZK rollup. And so I made the Merkle tree use Poseidon hash.
Got it.
I could probably just switch it to the upstream version of the tree. Okay, let's do that. So we don't do this one, we will do this. Just because Rust Analyzer, for all its faults, we do love it. And also for a demo, we really want to be able to look up definitions. All right, so let's see if I can go to this now, maybe. No, not quite. Yeah, it looks like I got to these three ABCI methods: init chain, prepare proposal, process proposal. Okay, she's done. Request init chain. Maybe not. My laptop sounds like a jet engine right now. So in a init chain, we look at the request.chain ID, and we check that the chain ID matches the chain ID of the one we're looking at, and we throw an error if it doesn't. And we also force the initial height to be equal to 1.
Why is it equal to 1?
Because this is the first block height should be 1.
Got it.
I don't remember why I forked Tendermint. Why did I fork Tendermint? See, Tendermint. Well, I can just add it to my workspace. Where's Tendermint? Here it is.
Yark was wondering what the link to the repo is.
What link to what repo?
I guess to Minnow.
Oh, sure. I can share that.
Thanks. Drop it in that chat. Cool.
So Tendermint RS has the ABCI module, and then, but maybe it's not in there. It might be in a stranger place. Yeah, it's in like this. So there's the Tendermint RS.
Is that just a Rust implementation of Tendermint?
Yeah, I don't know if it's an implementation, because I don't know if it actually can like be a validator, but it has all the types if you want to work with Tendermint types in Rust.
Got it.
So it has the enum for the requests, and there's like, init chain, begin block, deliver TX, end block, prepare proposal, process proposal. Begin block and end block and deliver TX, I think they're all gone. These are like obsolete with ABCI++. ABCI++ is the newer version of ABCI, which it has like better abstractions. But then you should be able to go look at what it is. Okay, finally, here it is. the request init chain is the one that I was currently looking at. So like init chain, Rollkit sends this to Minnow or to Cosmos SDK, but today we're looking at Minnow. And it says like the genesis time, the chain ID, and then there's this thing called the app state bytes. And this is where it gets fun. That's like kind of like the genesis state. So that's like everybody who gets the token when the chain launches. So let's look at how I validate the initial state. So what it does is it reads the app state bytes, 40 bytes at a time, and then for each 40 byte chunk, it deserializes it into an account balance pair, and then it writes the first 24 bytes into a 32 byte buffer. And then it inserts into the Merkle tree the key value pair. Oh yeah, right. This buffer thing is very ugly. It's because the Merkle tree requires the key value pairs to be 32 bytes. And so even though it's only a U64, we have to write it into this like 256-bit buffer. And then it sets the root. One thing I did not do is I did not write an actual store. So this, kids, is why you should not use Minnow. You should just use Synodarium.
But this is, I guess, this is how you would use Rollkit and ABCI outside of the context of like Cosmos. But I guess
yeah.
other examples
Yep.
that you give, the same deal.
But this is I'm showing you all a very crude piece of software, which is missing a lot of the important things that you want in a state machine, which is like a store, a database, telemetry, stuff like that. And then once it computes the state root and it loads all those user balances into the tree, we return a response, an init chain response. And we can look at that. The init chain response is here in the Tendermint crate. So it gives you the initial app hash for the chain after it executes the Genesis block, as well as these consensus params and a validator list. And depending on like how your rollup is sequenced, you may or may not do anything for that. In my example here, I just leave it completely empty, but I do return the app hash. So then we can look at prepare proposal. So let's quickly go remind ourselves what the prepare proposal request looks like. So the request prepare proposal, it gives you this max TX bytes. This, which is the juicy part, the TX transactions, which is a vector of bytes, a vector of byte arrays, and This is totally arbitrary. This can be like, you can structure this however you want. So in mine, what I did is I interpreted each transaction in that vector as a 136 byte buffer. And we start by just, oh yeah, and then we cast the whole thing into incoming block, which is a minnow type. So incoming block is just a vector of 136 byte values. Do I have any code for if it receives, if one of them isn't 136 bytes? I'm not sure, but there should be.
Not yet.
Not yet. I'll make it to do. So then we want to get an outgoing block. And to get an outgoing block from an incoming block, we call process. And process takes a mutable reference to the state. And remember, the state is this type that contains the Merkle tree. So process does a lot of stuff. First, it creates the outgoing block with the current state root as the header, and then it initializes this pairs vector. And then for each of the signed transactions in the incoming block, it deserializes it into a signed transaction. And then it calls verify and run transaction. And oh yeah, what it does is if any of them are invalid, it just ignores them. But if they are valid, it creates a signed transaction ISR pair. So that's just it's an ordered pair. On the left is your serialized signed transaction. On the right is the state root after executing it.
What's ISR?
ISR is an intermediate state root. So after you execute a transaction and you have the state root obtained from the result of executing it, you include it. And this is how a fraud proof works. You show that the intermediate state root was computed incorrectly. And Minnow seeks to make that very feasible by using share-aware serialization. So if one of these pairs is part of the blob and it's not valid, you can just show the share that contains the invalid one, and then that would work as a fraud proof. So process returns the outgoing block. And remember, that is just the header and the vec of these signed transaction ISR pairs. And the response to prepare a proposal the prepare proposal response is very simple. All it is a list of transactions which go into the block. So request prepare proposal has raw unprocessed transactions, and then the response is a list of the ones that are just the valid ones. So it basically filters out all the ones that are invalid. But also like the hacky thing that Minnow does is, even though this is supposed to be transactions, we return pairs. So ABCI expects you to use it in one way, but we do it slightly different because it was not meant for fraud proofs. All right, so that is how Minnow does prepare proposal. For process proposal, of course, we take the request process proposal, and this is like a completed block. So Rollkit or Tendermint sees the completed block, and we call that the proposal. The block is the proposal. And this gives you a bunch of stuff. So like one of them is the transactions. One of them is the proposer address. There's a hash, a height, and misbehavior, which maybe we could repurpose that into fraud proofs, but I'm not totally sure. So let's take a look at the Minnow one. All it does is it only looks at the transactions field. And again, we interpret these transactions as pairs. So all it does is it tries to deserialize it into a pair. And it succeeds unless there's a serialization issue. So Minnow's process proposal doesn't actually validate them, although maybe this is where we would put that code.
Can you
Okay, so
briefly cover what prepare proposal and what process proposal are?
yeah, so prepare proposal is when Rollkit gives you a list of transactions from users, when it gives your app chain a bunch of like raw transactions from users to like execute and to put into a block. And process proposal is when when Rollkit has a valid block and it wants your app to validate it / execute. The other one there's also finalized block, and then finalized block is after process proposal. So like process proposal is you execute and verify the block. Finalize is you actually save the block to your like database.
Got it. Thank you.
Yeah, you can kind of think of one way to think about like ABCI is Rollkit is a remote and your app is a VCR. So like like Rollkit controls the app with buttons on the VCR, and it's like prepare proposal is the fast forward button, etc. Maybe
Nice.
that makes no sense.
No, that's a good analogy. I guess if you know what a VCR is, but
Oh, true. I was gonna say DVD player, but I guess kids don't know what that is either.
yeah.
I don't know. It's like a Xbox. The consensus engine is the player, and the state machine is the console.
What is
Okay,
that?
so
Sorry. I was going to ask about the transaction flow, but I want to let you continue on the state.
Sure. Well, I mean, I was just gonna like try to figure out what tests I already had written and see if they're good. Where did I put my tests? Maybe here? Okay. So in VS Code, if you write a Rust test and you put this test above it, it lets you have a button to just run it.
Nice.
So here is the like test serialized transaction test, where we create a transaction where the sender pub key is 11111 and the recipient pub key is 22222, and he's sending 3,000 tokens. Oh no, Tendermint didn't build. Well, that's super not my fault, but I don't know why it's happening. It used to work.
Was it just built with an older version? Like your
Probably
initial
something, definitely something like that. Okay, well, let's fix Rust. Can you see my terminal?
Yep. We got your whole screen.
This is real world knowledge that we're demonstrating right here.
This is true life coding.
Yep, true live coding. So the time crate is throwing, and yeah, it's just the time crate which is throwing. So first thing I want to try when you get that is figure out what's going on with the versions of things. This is definitely not the newest Lumina. So what if I just upgrade Lumina? Everything else looks like it's pretty much the right. Maybe Tendermint is wrong. Okay, well, we can go and figure out, because Lumina probably uses Tendermint, so we can just use whatever version they use. Oh, they use this one, the Celestia Tendermint. So I'm just going to go ahead and this is going to break some stuff, but accelerate. Even more problems. Oh, I think I forked Tendermint and I added a bunch of like default traits.
Oh, so that's why normal Tendermint wasn't working, or the types at least.
Very likely, yes. I think I should have upstreamed those changes, but I guess I could do that on this stream. Why not? Is anything else weird in here? This tower is locked on a specific version, but that seems fine. This is fine. This is fine. I think it's just the Tendermint. I think I had some stuff in here for the like Celestia blob commitment in the header, maybe, or maybe not. I kind of want to rewrite this whole thing, but not today. So we have one issue with the time crate where they're trying to call derived defaults on a type. We have an unstable issue with this. We also have an unknown feature. And this is from the curve DALEC 4.1.1. Oh, but I was using version 2.1.0. So let's upgrade that. See if that solves anything. Oh, wait, 2.1.1. Okay, hold on. All right, most of the errors are still there, but did that one get fixed maybe? We can add this crate attribute to enable the feature. But I don't know what is even, because I don't import curve DALEC. I import ED25519 DALEC. There is some way you can look at dependencies. I don't see. Okay, maybe hold on. We'll grep for it. But but that doesn't show me what crate imports it. Okay, never mind. Back to the drawing board. Let's try adding this line to the root, the crate root. Maybe that'll fix some errors.
Looks like it's appearing in a few.
That didn't do it. Try updating Rust, I guess. Does that do anything? Maybe.
I guess in the meantime, if anyone is curious about where they should go for this, I think the GitHub repo is the best place, right?
For what?
For like checking out Minnow and learning more about Minnow.
Sure. Yeah. It's I would say, like, if you're curious about this weird code base I made, then yeah, check out Minnow on GitHub. The link is in the stream. But if you want something that's more batteries included, you should check out Snidarium.
Do you mind
the link
dropping a link to that? Yeah.
Yes.
Nice.
Here's the link to the upstream code, and then I'll put the link to the usage in Astria as well. Okay, I think this actually might be kind of working. Oh, nope. Okay. Less errors now.
Nice. We did lose your screen share though.
Yeah, I'll put it back in a sec.
Yeah, no worries.
Here's the Astria code that uses Snidarium. All right, back to doing this. Okay, so now the errors are actually from my code, which is great. So need to fix the import of Tendermint. Looks like it's pretty much the same structure. So I can just go replace Tendermint with Celestia Tendermint. Okay, 5 errors. Now we're down to 3. There is no 0.38, which is weird. I guess we have to do 0.37. Okay, now we're back up to 6 errors. That's fine. You know how it is with Rust. Oh, shit. What happened to 38? Okay, it actually is missing the finalized block types. One cool thing we could do is just remove it. Haven't got to that part of implementing ABCI anyway. But let's see if it exists. GitHub, Eiger. Where on earth is Celestia Tendermint RS? Yep, Eiger owns it. There's the Tendermint folder, and there's 3.4 and 3.7. Let's see if there is 38 on the informal systems branch. Yes, okay, so informal has 3.8. Eiger does not. So that means we need to somehow update it if we care about finalized block, which maybe we don't because maybe Celestia doesn't have finalized block, but regardless. Also, maybe Rollkit doesn't want Celestia Tendermint. How much
What do
time
you
we
mean by
got?
that? We have another minute, but
so it's possible that Rollkit communicates over a newer version of ABCI than Celestia supports.
sounds like it can make sense.
Because Rollkit is not quite the same thing as Celestia. Celestia is a layer 1 blockchain for data availability. Rollkit is a framework for building chains on top of DA layers.
So keeping the kind of people, I guess, hacking in mind, are there any things that you'd like to see built during the hackathon, or any ideas you have for people who are curious about using Rust and Rollkit?
Yeah, I mean, this whole area is certainly for builders who want to get their hands dirty, who are like most interested in doing some trailblazing on the frontier, because Snidarium, tower-ABCI, and Minnow are not as beginner friendly as Cosmos SDK. So if you are interested to use Rollkit appchains with Rust, you're going to need to do a bit of trailblazing, but there's starting to be a big community around it. So you'll certainly be able to get people to reply to you on Telegram if you decide to go down this trail. Otherwise, if you want something that has lots of tutorials and way more examples, and you don't mind writing Go, Cosmos SDK is great.
And do you have any last things to share for people? Maybe places to contact you, or last
Sure.
word?
Yeah, I respond to all DMs on Twitter, and I respond to Telegram as well. Twitter is colluding node. Telegram is my name.
Cool. Awesome. There aren't any questions in the chat. I've exhausted my list, but I had a great time learning, and want to thank you again for joining to teach us about
thanks for watching.
appchains and Rust. I'm sure all the Rust heads will like it. So yeah, if you're watching the stream after the fact, I would say that Discord is also a good place to chat about this, no matter what team you're on in the ISP. But yeah, thank you again, and thank you everyone for joining, and wishing everyone a good rest of your day.